morning, everyone, and welcome to the second session of the conference proper. This morning we have got Kate Chapman, who's the Executive Director for the Humanitarian OpenStreetMap team, which utilises OpenStreetMap to create free geographic data for disaster preparedness, response and recovery. Her most recent work has been in partnership with AusAid and the Indonesian National Disaster Management Agency for building OpenStreetMap's community to develop infrastructure disaster using that, and in particular in Jakarta. So please everybody give Kate a very warm welcome.
Good morning. So I'm going to give a little background to start. I know OpenStreetMap was mentioned in the last presentation, but just to make sure everyone knows what it is. We like to use this equation. Basically, OpenStreetMap works like Wikipedia, but the goal is a free map of the entire world instead of a free encyclopedia. That means anyone who signs up for an account with an email address can contribute information, fix mistakes, that sort of thing. So the project's been around since 2004. So the National Mapping Agency in the United Kingdom, the Ordnance Survey, their data was very, very expensive. So Steve Coast needed some map data for a project and said, why don't I just make my own? July 2005 was the point where there was some infrastructure where you could actually create data. People got together and had their first mapping party, as we like to call it. Talking to a technical audience in open source, you probably can understand why we might need a free world map, but I'm going to go through a couple of reasons anyway. The typical, it's expensive. Data, information can be very expensive. The other thing is proprietary data. Vendors typically will put mistakes in it, Easter eggs, things like that, to determine whether or not you've stolen their data. You can't fix it either. So, with OpenStreetMap, if your street's wrong, if your favorite restaurant's not there, you can just log in and add it. So HOT, the organization I work for, we specifically use this OpenStreetMap, this open data, for disaster response and disaster risk reduction. Why? Same reason, data is very expensive or sometimes doesn't exist. In the majority of the places we work, there isn't a really good detailed map you can use for planning. So we got started as an organization after the January 2010 earthquake in Haiti. So on the left is the OpenStreetMap map before the earthquake. Someone had gotten some public domain data and had imported it. You can see it's just some major roads. 2 weeks after the earthquake, there was a very, very detailed map. So what happened was very, very organic. Earthquake happens, someone starts just tracing satellite information. So it's just a satellite image, copying over roads, looking for other free data. There was some maps from the US government that could be used, and people didn't really talk about it, a specific effort. It was sort of just IRC chatter. Well then, the World Bank, the United Nations, all these organizations start using that data. This is a GPS unit from a search and rescue team. I don't think the person who took it thought this photo would end up on TED Talks or this presentation at the time. But the way we got it was he had just posted to our wiki, hey, this data's great, I'm using it to get around with my team in Port-au-Prince. And so we view that as one of the really important things, is anyone can download the data and use it. A lot of times we don't know who's using it. So starting in March 2010, some of these large organizations said, well, why don't we bring you to teach people about this? We think this OpenStreetMap thing is really useful, but up to that point it had really only been this international sort of organic volunteer effort outside of Haiti. So we started going down, and you can see from the pictures, we really taught everyone from UN peacekeepers to people from civil society groups, the International Organization on Migration, etc. And we were still sort of just a gaggle of open source geeks. And later that year, someone said, well, we sort of need an organization. We want to write a check to one person, basically, to one organization, not organize with all of you, and we're worried about liability, that sort of thing. So that was how we got started. How I got started is I just sort of was an OpenStreetMap person, was mapping my neighborhood, and after the earthquake happened in Haiti, I worked for an organization that did geographic data sharing, and they sort of let me do whatever I wanted for 2 months, which ended up being OpenStreetMap. A little aside from that, prior to that, I worked for technology companies that had proprietary software and closed data that helped the US government share information through sort of a web portal. So during Hurricane Katrina, I charged $100,000 worth of data to someone's American Express card, and then we sold that to the US government for, I have no idea how much money. So I consider some of this, I need to right some wrongs that I've done. It's also why that data is so important. I don't think today in the US the same exact scenario could happen, but there are still variations of it that would. So back to Haiti, we have been training all sorts of teams. This is a team in Saint-Marc, which was not affected by the earthquake, but the value of the data there is seen. So we trained, I think it was 40 youth, which I think is vaguely like people like 16 to 26 or something like that. And the goal was it helps them with employment, get some tech skills, and also there's a basic map of Saint-Marc now that the government can use. This is the map. It's so detailed it's a little difficult to see from where you are, but this general like hospital and business information wasn't readily available in a format that anyone could use before. What's been cool though is, so we focus on disaster response and preparedness. We're starting to see these other uses of the data though. So this is Cité du Soleil, which is the largest and most notorious slum in Port-au-Prince. If you remember videos from the 90s of people with AK-47s on bicycles riding around, that's where that happened. This project actually though is mapping the change within there. There's movement with the people that live there to clean up block by block. And so they actually use OpenStreetMap to keep track of that, where they've gone and removed graffiti, cleaned out sewers, things like that. So I view it as more creating an ecosystem around data. We want to prepare for disaster, people want to clean up their neighborhood, this can all work together. Here's another project. So a TapTap is the informal bus system in Port-au-Prince. And I guess you just ask someone to know where to go. There's no specific map of it. So a group of people have ridden the bus routes and have started to map them as well to have more information available. And the base of that data is still that information originally created after the earthquake. So today, this is where we work. So I live in Jakarta, and then we also work in 5 countries in Africa as well, and this is all primarily technology training. So in Indonesia, I started working there in March 2011. What had happened is there's a project. There's a facility called the Australia-Indonesia Facility for Disaster Reduction, which scientists from Geoscience Australia actually live in Indonesia and help with the Disaster Management Agency better use science to make decisions around disasters. So we ended up getting hooked up with them, and the reason was, so they were building this open source impact modeling software. So the goal was to take scientific data and infrastructure information and say, okay, if there's this type of flood, how many schools do we need to close? If there's a tsunami, how many people are affected? It's great to have the open source software, but if you don't have data, it doesn't matter. So we came in to help teach people how to make create data so that it can be used in this software. It's built on top of Quantum GIS, which is a desktop GIS, and the actual software is called InnoSafe, and it's a plugin for it. So to get people mapping, we really, the first year had a lot of leeway to do many things. The first one was we started meeting with local organizations who were already doing mapping. This is a poverty map, which it's actually probably about as big as it's being displayed here. And all those little dots are sequence. So someone lays out a map or a piece of paper, the village gets together and decides what it means to be poor, where are the resources, where are the schools, where are the toilets, things like that. And then at the end, they end up with this map, so they can look at how the resources are distributed. Let's say you want to change the poverty indicator. You have to pull every sequin off of that map and re-glue it on. So what we did is we came in and said, we'll show you how to do this digitally. You can still have your map because you can print it, and you can make a lot of different types of maps as well. And what's been interesting is I thought they would print a lot more. Really, they just go around with a projector and the OpenStreetMap software and discuss with people, which is pretty cool. The other thing they let me do, which I thought was pretty amazing, was I got to have a mapping competition. So we worked in 5 universities, and it was whoever could map the most buildings. You got 5 points for mapping a building. We wanted to know the type of roof, the wall type, the construction of the building, what it was used for, and the number of stories. And you also got 1 point for mapping anything else, like if you mapped a road or hospital or anything like that. The prize was the equivalent of 22 million rupiah, which is basically a trip to FOSS4G, the free open source geospatial conference, which happened to be in Denver, Colorado in the United States that year. So here's the crew. So it was really kind of cool to be able to teach people open source software, but then let them meet the community. The one unfortunate thing is no one ever mapped anything again, so no one's going to probably ever let me do a mapping contest again. But it was interesting to try different things. And actually, some of the people are still on my team today, so it's unfair to say they never mapped again, but everyone, but there were a couple people who were interns and trainers. The other thing we did, and this is sort of like an Oscar acceptance speech, but is we worked together to map Jakarta with the National Disaster Management Agency, the regional one, the United Nations, AusAid, my team, and the University of Indonesia. So what we did is we printed a lot of these maps. A couple of us, it was a Sunday night and it was 3 a.m. and we were fiddling with paper to make digital maps. And what we then did with them is, so there's this idea of urban village heads in Jakarta. There is 260 odd of them. So we had 6 events where we invited them and we set them up with a student and just asked where stuff was in their area. And so we use the paper maps for the discussion to mark things down, and then the students help them enter it digitally and upload it to OpenStreetMap. And along with mapping things like, so every urban village has a health facility, for example. They have schools. They also have boundaries, which are like the neighborhood boundaries. And we mapped those boundaries as well, and we said in 2007, did this neighborhood flood? Yes or no? Sort of a simple historical record, but that was what we did. So this is 2 weeks ago. From the bus, I was going from the airport to my home in Jakarta. There's been significant rain there. About 40,000 people have been displaced and 9 people died during this flood. And here's another shot. This is actually from the truck of the one of the regional disaster management guys said, hey, do you want to go up to North Jakarta and see? But it wasn't all just looking at floods and being shocked. Oh, there we go. So this is an official map showing the some of the flooded areas, and then there's also information about displaced people, which is hard to read at this scale. But this is an official map from both the Disaster Management Agency, the national, and the provincial one. It's using the OpenStreetMap data that we collected in March as a base. I think this is the first time that there's been an extensive preparedness exercise, which is then in turn fed into an actual response. And this is continuing to be updated. A team went out on Thursday because there wasn't information of where the coordination centers were. People in Indonesia don't use, the government doesn't use maps a lot. We're trying to help with that. So you have these lists, and it says, okay, these are where all the coordination centers are. But you have no idea really how far away they are from each other, or the other nice things that maps tell you. So, so that's sort of where we've been with that part of the project. Secondarily, separate from the Jakarta part, over the past year, and this is why I was taking a bus from the airport through the flood, we've also worked in 6 other provinces to teach, to do the same sort of preparedness exercise. We're not inviting all the government officials to come and entering the data for them this time. We're actually working with them and university students. So there's 2 parts to it. First, my team comes in and teaches people about OpenStreetMap. So we teach them how to use GPS, how to read satellite information, and how to enter data. A second team also then follows behind us from a university in Yogyakarta, UGM. And then they teach them how to do the actual analysis. So the idea is, look, if you collect this data, you can then do analysis, and then you can make a contingency plan so that if a disaster does happen, you can do something about it ahead of time. So we've just finished, so we've been to all these places twice. So we've just finished sort of our initial set of training, and next up is people are collecting data in specific areas, and they can request technical support from my team. My team is 8 rather new graduates from Indonesian universities who have geography degrees and then have spent the past 3 or 4 months with me learning about open source, a little bit of programming and that sort of thing. Prior to working with me, they were entirely trained in Esri, which is the typical software that's used, so they've been learning sort of a different approach to things. So I actually didn't have a lot of good shots for this one. This is actually volunteers from Europe. We support people in 4 countries at the moment. It's the idea is to send volunteers for 6 months, 6 volunteers to go work with local NGOs and government and help them with information management. So OpenStreetMap is part of this, also Sahana Software, which is a web-based crisis management system. And so we support them by at the beginning of the project, people from our team went for 3 weeks to sort of get them set up, help them interact with the typical development and humanitarian organizations like the United Nations or the World Bank or local groups to organize projects. One of our teams was in the Central African Republic. They've actually been moved because of basically there were rebels going towards the capital where they were based. They closed the US and the French embassy. Everyone's safe, but it has caused us to have to change plans a little bit. And that sort of goes back to, there's different types of disasters. The disasters my project personally works on are very natural disasters, but a lot of the work that these guys are doing are more man-made conflict type situations. So in addition to all of this running around and teaching people, we also do a lot of documentation. This is our website, learnosm.org. So this came about because there is a ton of information on OpenStreetMap. The OpenStreetMap wiki is full of stuff. Try to find the stuff that you want, it can be very, very difficult. So Jeff Hack, who was a person on my team for 6 months in Indonesia, and Amir Hartado, he's still on my team, they did a a workshop one day and it went really badly. And the two of them together get a little emotional about these things. So they were really upset and they stayed, they worked all weekend and made their own set of training materials, which turned into this, and we've put more work into as well. And so when we initially released it, it was only in English and Bahasa Indonesia. And I think releasing things in two languages, one which people consider common and one which a lot of people speak but people don't think is common, is a great way to get it translated. Because so many people came forward and they said, this is in Indonesian and it's not in French or Spanish or Japanese or whatever. And so we got a lot of translations really, really quickly. This is in WordPress at the moment. We're switching over to a system where we're using GitHub Pages and using Git to do version tracking, which should be moving over in the next week or two, hopefully. The hardest thing with that actually has been, like with my team, I hadn't taught them Markdown yet, so getting everything converted has sort of been an adventure. But the idea with that then is, so if someone updates the English version of a paragraph, it can filter back down that the translations need to follow, because at the moment, updating's a bit difficult. Another thing that we did that's related to that, Google Summer of Code had a documentation sprint about 1.5 years ago, and we wrote the first free and open OpenStreetMap book. It was actually based on the LearnOSM materials, which are licensed CC0, so taken and created this book, great. People are remixing. And then that got translated into French. So we did a Kickstarter to translate it into Haitian Creole as well. So a lot of people in Haiti speak French and Haitian Creole, but if you want to reach everyone, it has to be in Creole. So the translation sprint happened in December. It was relatively inexpensive to do this. We raised $2,577, and what that covered was someone who's an expert in documentation and translation, and a floss manual system specifically to go to Haiti, and then lunch and snacks for people who volunteered to translate. So the translation's done, and we're going to be, we have a little more cleanup to do, but then it'll be something that people will be able to order from something like Lulu Press and get it delivered to their house. And we will probably be converting LearnOSM also into Haitian Creole as well. We sort of have this weird two sets of documentation at the moment, but at least there is documentation. So this has nothing to do with OpenStreetMap, but it was something we accidentally did. So every 3 months at Camp Roberts, which is a old military base in California in the US, there's these sort of disaster response, I think they call them experiments, which means you might fail, I think. Meaning that you can get people together and work on things, and there's sort of like but anyway. So 2 of us went there, and the reason was in the US there's a group called the Civil Air Patrol. It's the US Air Force Auxiliary. Every time there's a disaster, they go fly Cessna planes. They have over 500 of them around the US, and they take pictures of the disaster. They were just handing those to people within the Incident Command Center, and nothing was really happening. These are geo-referenced photos, so you know where you at least know where the plane was while it was taken, and pretty high quality, SLR camera type deal. But they were, people were overwhelmed what to do with these thousands of photos. So what we did is we met with them and then FEMA, the US National Disaster Management Agency, in the same room, and discussed how we could make the process better. And so what we had done is there's some software called MapMill, which was created by the Public Laboratory Group. They do balloon mapping and that sort of citizen science projects. And they designed it so you could sort through your photos you took from a balloon really quickly and just say good or bad, and then you could geo-reference them. So what we took the software did is we said, okay, we're going to let people rank it. Say, okay, some damage or bad. And we're going to be pretty vague about this. So we built a working prototype in that 3 days at this exercise, and then we also had them run some flights. And just by running through the process, we figured out other things. So they were flying the aircraft at about 1,500 feet to 2,000 feet, and they said, and the FEMA guy said, you know, if you flew the aircraft higher, that would be better for that. And the pilots were like, well, it's way easier to fly the aircraft higher as well, as far as clearance in a disaster area and everything else. So we worked out a lot of things. Then Hurricane Sandy hit the east coast of the United States, and Skylar Earle, who worked on this with me, said, hey, I'm going to set this up, we'll pull in images and see if we can be helpful. So within about 6 hours of setting this up, the server fell over because so many people wanted to help, because we just didn't think we would get a big audience. So 6,000 people sorted, I forget how many thousands of images over the course of a week. And what this information is used for is to create these grids. So this is the equivalent, basically military grid reference system. We call it National Grid if it's of the United States. And it ranks how bad the damage is based on those pictures. And this is a really rough estimate, but this allows people to actually be dispatched to go do an on-the-ground assessment. And so this was the first time it was used. Don't know if it'll be used again, but the source code is out there, and we're working on improving the process, as well as we have we took a subset of the data and had up here. This is Padang City, which is in Sumatra in Indonesia. We had bought satellite imagery for the whole city, and we wanted to map every building in it. So we set up this task, and it took about 6 months or so, because it was over 100,000 buildings and going and drawing a square around them, basically. But we finished it, and we have a ton of other tasks up there as well. So if all this sounds interesting, a great way to get started is simply with your OpenStreetMap account, log in here and see what people are being asked to do. This is actually a relatively new task. So when we decide to do something in response to a disaster, we have a discussion and then we activate, which means we've reached out to partners, we've discussed it internally, whether or not we could be useful, that sort of thing. So this, on Monday, we activated to collect data for Syria. And this is outside of Syria, meaning diaspora and people who can know the area or can trace satellite data. Because there's a lot of ethical concerns and issues with trying to work with people inside the country at the moment. So we're working with the United Nations and Map Action. Map Action is a group where it's a volunteer group, primarily based out of the UK. When a disaster happens, they say they can be on the ground within 48 hours. So they've been active in Haiti, the cyclones in the Philippines, and any major disaster that you can think of, they're providing maps to responders. So we work quite closely together with them. And then the United Nations Office of Coordination of Humanitarian Affairs as well. So this is a map from yesterday. So they've already started beginning to use the data, and we'll probably use it more as things are, as the data's improved. We're currently working on recruiting Arabic speakers and people who know where things are in Syria. When there's a disaster, there's a coding system called place codes, and it's a unique identifier for each geographic place, so that you can have a place and it can have the local term, the local name, the name in English, the name in some other language. There's 900 of locations that have P codes assigned to, but they don't know where they are. So we'll be working towards finding the places, basically. So we'll see how that goes. We're also working to collect data in Mali, and the Central African Republic as well. And in all these cases, we want to work with people actually doing response. In Haiti, Haiti people sort of started mapping, and then people sort of started using the data. But you can't always be effective. Maybe there already is data. Maybe the government has open data that's available. So we try to work where we can be useful. And we find a lot of time, usually there's some need for our assistance. But it's also a matter of, we only have so many volunteers, so getting more people involved allows us to do more. Yes, so we need help. We actually create software. So the tasking manager I showed you is completely created from scratch within our organization. It was created basically out of a specific need. AusAid funded the initial development of it, and actually any development that's happened since has actually been mostly that one volunteer in his free time with occasional bug patches. Examples of patches that have happened is, so Digital Globe and GUI, which are now one company but are large satellite providers. When you zoom around in Google Earth, you're probably looking at their information. They're US-owned companies. The US government has a license to any pixel that they take, and they can share it with organizations that they're working with. So they had come to the conclusion that it was okay to share it with OpenStreetMap. But needed a click-through license that just said, okay, sure, I'll only use the data for OpenStreetMap. So that's the type of patch where it was vital to us having satellite information so that we can actually help people, but a simple software patch was required to make that happen. We're always training people, both remotely and in the field. We do a lot of internship programs where we sponsor people to come with us places if they have a specific skill or in the future would like to work with us more. Actually, this weekend, someone's been doing a 6-month internship with me in Jakarta. She's been living in my guest bedroom, so it's possible someone else could move in if the circumstances were right. But we try to train, we try to train people, because there's a lot of people we work with that have great technical experience, but no international development experience. They've never worked somewhere where maybe the internet access is terrible or non-existent. Maybe the power goes out in the middle of your training. Those sort of typical things that when you've worked in those environments, you learn to get around, but it requires actually experiencing them, I think. As I said before, we do a lot of just mapping. Simple, we call it armchair mapping, where sort of munging data, looking at other information, and adding to OpenStreetMap. We always need help with outreach. I travel around a lot. There's a couple other people that do as well. And some of that is attending conferences like this, but also, for example, I attended a couple of United Nations trainings and meetings in December because we want people to use the data, so they have to know about it and know the circumstances that they can use it and sort of how things work. We also, this is sort of a recent one, people want us to be using UAVs, but the current software and systems available that appear to work smoothly are proprietary. We really don't want to be, and there are getting to be better options out there, but we don't want to be spending a ton of money on systems that aren't sustainable that we can't share with other people. So that's way down on the wish list, but I'm mentioning it. So there's a lot of ways to get involved with us. And it's simple, our website. It's a big link that says get involved. It's a list of things to do. Okay. And any questions?
Microphones for questions, or? Yes, please. Just for sort of in reverse order in some sense, the drones, have you talked to Tridgell, who's here on conference and doing open source drone
controls and things. I don't think it's probably worth having a chat while he's here. And then going back further, the working on tracing the buildings, to me that's the kind of thing that like you need to get a university mob doing image recognition and going, hey, look, we can draw these spots. Like maybe a medical imaging group who normally like circle out cells and other funny little things that similarly have odd fuzzy edges would be a good one. I'm happy to have a
it's been interesting so the reason we do everything super manually is there aren't a lot of good algorithms for those those specific detectors, and we have a lot of manpower and not a lot of super scientific expertise.
Sure, but maybe we'll have a chat about that after. And otherwise, how do you find, like how much of the data collection is sort of out in the field and hampered by lack of telecommunication?